Hi kids, it's me here, and it's chemistry fun time. I'm your host Brian, and that is your co-host,
me! The first atomic theory was thought of or proposed in 400 BC by the Greek philosopher Democritus, who saw wind blowing and moving things and assumed that because they were moving things, that there must be some sort of small particle there. But this hypothesis was refuted by Aristotle and Plato, because he really had no proof. These two believed that everything was made of continuous material called Heil. Now I bet you're wondering what I'm drawing here, but let's find out. Let's go!
Hey, I'm Democritus, and I'm here with the latest and greatest in chemistry. Check this out. You see, now I know wind has mass. Yeah.
Nuh-uh. Me and Plato don't think so, Democritus.
What's your argument?
Well, this is obviously continuous material, Heil. Check it.
Psah! Stupid. Ugh.
What a chump, eh, Plato? You can turn it off now. Welcome back. Now, let's move forward about 200 years to 1803, where scientist John Dalton did something very important. But now, let's turn to our studio audience and see if they already know what John Dalton did that was so important. Enrique here thinks that I'm asking a trick question and that John Dalton didn't do anything. You're not right, Enrique. Sally Sue here, she thinks that John Dalton invented milkshakes, but that's not true either. Ramses over here thinks that John Dalton may like to play ping pong. Now, while that may have been true, Ramses isn't right either. But Wang Chong here thinks that Dalton invented 5 of the crucial atomic theories in chemistry. And he is right. Good job, Wang Chong. Now, let's find out what exactly those theories were. Come on, kids. You ready for an adventure? Let's go! Now, John Dalton's first atomic theory was that all elements are composed of small particles called atoms. So, for instance, this blueberry is really composed of a bunch of tiny little atoms that are so tightly close together that you can't even see them. Now, atomic theories number 2 and 3 sort of go hand in hand. Dalton said that atoms, number 2, was that atoms cannot be created or destroyed. Dalton's 4th law was that atoms of the same element are the same. So let's take, for instance, a strawberry. All strawberry atoms are the same, but all atoms are different than other atoms. So the strawberry atoms are different than the Christmas tree atoms. Now, his 5th atomic theory was that compounds are formed when atoms of different elements meet. So let's take this element. Now we know that that's not nickel, it's sodium chloride. So pretend that these are sodium ions, or sodium atoms, and these are chloride atoms. These all mix together to form table salt. Alright, now let's move forward in time almost 100 years to 1897, where scientist J.J. Thomson discovered that an atom is not just one thing, but it has a substructure and is surrounded by things called electrons. And he did this by using his very famous cathode ray tube. Come on, guys, let's check it out.
Okay. This is J.J. Thomson here with the latest and greatest in chemistry once again. Here I'm going to show you that there's totally electrons in this thing. Watch this. This piece of white is very negative. So as I put it here, the light bends away from it. This obviously makes it negative. I'll call it electrons.
From this, J.J. Thomson developed a model of the atom, which was what he called his plum pudding model, with electrons just kind of sitting around in this big, squashy blob. Now, let's move forward a couple of years to 1910, where Rutherford conducted gold foil experiment. Now let's check it out.
This is Rutherford here with the latest and greatest in chemistry once again. As you can see, I have an alpha particle box with a big red button on top, and I'm about to turn it on and see what happens. I have some gold foil in the circle around the outside, and I think they're going to go right through. It's going to be awesome, guys. Let's see. Okay, let's see what happens to these dudes. Okay. Whoa, some of them are going through. Oh, but they're bouncing off. This is crazy, guys. This, wow. I used to think that plum pudding thing was pretty cool, but I'm just going to have to make my own thing now. I'm going to call it the orbital model. Check this sweetness out, kids. It'll change your lives. Yeah.
Through Rutherford's gold foil experiment, he discovered that that atoms have a small, dense nucleus that is surrounded by electrons. Now, his model looked a little something like this. Here's the nucleus, and the electrons are out here. This disproved Thomson's plum pudding model, and this is the model that we generally use today. You too.
Hi kids, I'm back with Chemistry Fun Time, and it's Brian and me! But I would like to inform you, Chemistry Fun Time is almost over.
What?
Yes.
Oh!
Yes, James. I know this is a fun program and all, but it must end now. But before we go, I need to leave you with one last thought. Chemistry is fun.
Time!